We're going to look at histograms, frequency polygons, ogives, or some graphs of our grouped frequency distributions from the other day. Each of these graphs has certain characteristics that go with the particular graph. So as I just mentioned, a histogram is one of our graphs. A frequency polygon is another graph. And an ogive is the third graph we will look at. So frequency polygon and ogive. Histogram basically has two characteristics that set it aside from the other two. Number one, it is a bar graph. So this is a bars, not bats. So it can contiguous vertical bars to represent the frequencies of each class. So our frequencies will be along the y-axis. And the other characteristic besides it being a bar graph is along our x-axis, or the horizontal axis, we will use the class boundaries. So when I say horizontal, that is the x-axis. So those are our two characteristics here. Bar graph uses the class boundaries. Our frequency polygon has three characteristics that set it apart. Number one, instead of using the class boundaries, we use the class midpoints. When I say use the class midpoints, that would be along our x-axis. It is a line plot, so to speak, so we plot the points and connect those by using or connecting the lines that connect the points. And the third thing is the edges of the graph are closed down to the horizontal axis to make it a polygon. If you're familiar with the definition of a polygon, it's a closed-shaped figure, so our polygon is basically a straight edge to the x-axis at both ends of that line plot, so it makes a polygon or closed-shaped figure. And then our third graph here is an ogive. Ogive is a cumulative frequency graph. That's the biggest characteristic. So along our y-axis will be the cumulative frequencies going from 0 on up, which means our graph should continue to move up from left to right. They won't have any peaks and valleys like our other two graphs will. And then notice that it goes back to class boundaries. Okay, so once again, as a quick review, histogram is a bar graph that uses class boundaries. Frequency polygon is a line plot that uses the midpoints and the edges are closed at the front and back side. Ogive is a cumulative frequency graph. It's a line plot, and we use our class boundaries. So that leads us to our first example here. We have a group distribution from yesterday. This is a sampling part of our record high temperatures from our note packet. I'm going to try and draw, I'm going to do the first one right over here and see if I can't squeeze all three graphs down here at the bottom. So our histogram is where we will start. This is our histogram. We will put our boundaries down here along the x-axis. I'm just taking a quick moment to plug those in. Okay, so I squeeze those boundaries there. The other part that makes this a graph, or an important piece of this, is looking our frequencies go from 1 to 18. So we don't want to probably go by half a units here. Typically what we'd like to have probably here somewhere between 8 and 12 tick marks to make this graph somewhat presentable or usable to whoever might be looking at it. So we go starting at 0 and go up through up to 18. I'm going to go by 2s for our frequencies, and I think that will give us a pretty good picture of how that information might be spread out. So choosing that scale is somewhat important. We don't want to go by 10s. We just go 10 and 20. Our graphs being very compressed. Where, like I said, we don't want to go by half units because we'll have a huge graph. So we want to pick something that gives us a good visual representation of what the information is saying. And then all we do is, for each of our boundaries, or each of our classes, we set our frequency. So we have a bar graph here. Our first class has a frequency of 2. Then we have a frequency of 8. Then we have a frequency of 18, a frequency of 13, of 7, and of 1 and 1. So there's a quick sketch of a histogram. Okay, again, pointing out that we have bar graph. We use our boundaries down here. Hopefully those are legible. Those are the boundaries right off of here. And then choosing our scale, once again, is an important factor in our histogram. From here, we'll move on to our frequency polygon. So I'm going to try and sketch that X and Y axis over here. Our frequency polygon uses the midpoint. So if I add 99.5 and 104.5 together and divide by 2, the midpoint is 102. 104.5 plus 109.5 divided by 2 is 107. And then you'll very quickly pick up the pattern there. Those are our midpoints. I'll just place those there. So I'm going to mark those down here. 102, 107, 112, 117, 122, 127, and 132. Looks like we're graphing our actual numerical frequencies here, so a good thing to do would be the same scale we had previously. So I'm going to go by 2s and put that as my scale. And what we did left off of this one was these are our temperatures and these were our number of states. So we probably want to have a little bit of a descriptor item there so that people know what this information represents. So these are our record high temperatures. And again, these are our number of states. I'm going to get this out of the way a little bit. Number of states. Okay, so with our frequency polygon, we're going to do a line plot. So we have a frequency of 2, a frequency of 8, of 18, of 13, of 7, of 1, and of 1. Our line plot connects those points. Boom, 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 and boom. And the last part of this is it's a frequency polygon. A polygon is a key phrase there. So I connect my graph to the x-axis at each end. So it closes off that shape. It's now a closed shape figure. That would be our frequency polygon. And I'm going to scroll down here a little bit more and try and put in our graph for the ogive. Our ogive is back to using the class boundaries. So I'm going to start by filling those in here. And the other part of an ogive, it's a cumulative frequency graph. So I'm going to go back up to my graph here and put that cumulative frequency column in here. 2, 10, 28, 41, 48, 49, and 50. So you can see here we're going to have a different scale. We're going from 0 to 50. So if I go from 0 to 50, I probably don't want to go by 2s anymore. That's going to give me 25 tick marks. So rather than go by 2s, I'm going to go by 5s. So I go 5, 10, 15, and so on. Now I'm just sketching these freehand on our notepad here. For our homework, for anything else, we can probably use graph paper to make things a little bit neater and easier to read. So there's our ogive set up. I'm going to mark this as an ogive. I'm not going to put the labels on here. We already know these are the number of states and these are record high temperatures, so we can just carry that down from one to the next. But there is one other basic characteristic to keep track of with our ogive is we will always start here at 0 on that first boundary. Okay, again, always start at 0 and then graph the cumulative frequencies essentially at the end of each class, right at the last boundary here. That becomes an important process that we use this graph later on to read out percentiles. So we have a frequency of 2, then we jump up to 10, then we jump up to 28, then we jump up to 41, then we jump up to 48, 49, and 50. So notice, as I mentioned, we went over this, our ogive continues to move up from left to right. Okay, so there's an example of a histogram, a frequency polygon, and an ogive using what I call the raw frequencies or the numerical frequencies. I'm going to scroll back up here because our next set of problems, our next set of graphs is called a relative frequency graph. The only difference between what we just did and a relative frequency is we change these frequencies to ratios or percentages by dividing the frequency by the total number of frequencies, and we're going to change our y-axis to be those ratios or those percentages as opposed to the numerical values that we had here. So that will look like this next problem that we have here. We have the same distribution, but I'm going to do two things here. I'm going to put a cumulative frequency column on here. We've already had that up here. That's 2, 10, 28, 41, 48, 49, and 50. I'm going to put a relative frequency column on here. So relative frequency takes, I'll just write it out here, it takes 2 and divides it by 50 to get 4% or 0.04. It takes 10 and divides it by 50 and gets, I need to backtrack here, let's start over. My relative frequencies, I don't want my running total just yet, I just want my regular relative frequencies. So when I put that column on here, I'm going to take the 2 divided by 50 to get 0.04, the 8 divided by 50 to get 0.16, 18 divided by 50 to get 0.36, 13 divided by 50 to get 0.26, and so on. So those are my relative frequencies. And just to have everything together, to go ahead and graph the ogive as well, I'll put the cumulative relative frequencies in another column over here. That way we're all ready to go with all three of our graphs with setup information. So here I'm either taking each of these and dividing by 50 or just going here and do that running total. So 4% plus 16 gets me 20, 20 plus 36 gets me 56, plus 26 is 72, plus 14 is 86. Oops, how about a 82 and a 96? So let's fix that. Math skills are lacking here. Oh, so I have 82%, 96%, 98%, and with a cumulative frequency, we should always end 100% or 1.0. Okay, so there's our setup. Past that, we'll start with our histogram. So trying to sketch our x and y axis here. Our histogram uses the boundaries, so I'm going to label those on here, 99.5, 104.5, 109.5, 114.5, 119.5, 124.5, 129.5, and finally 134.5. Our relative frequencies go from 4, or actually from a low of 2 up to 36. So we think we'll go by 4% here. So along my x-axis, that will give me 9 tick marks when I go from 4 to 36%, which is probably about ideal. So I have each of these numbers going by 4s. I didn't leave myself enough space. And I'll go one above that to 0.4. And as we discovered previously, our histogram, which is what we're doing here, histogram, is our bar graph. So our first one has 4%. Our second one has 16%. Our third one has 36%. Oh, we then have 26%, 14, 2, and 2. So done correct. We use the same type of scale. If you notice on our numerical frequencies, I had 10 tick marks, which is what I have here. The graph is going to look pretty much identical. We just have different numbers here along our y-axis. We have those ratios or those percentages instead of the numerical values that we had with the raw data. I'm going to start over here with our ogive. Our ogive, as you recall, uses the class boundary or class midpoints. So I'm going to put those in here from our previous problem: 102, 107, 112, 117, 122, 127, and 132. I'm going to use the same scale because we are graphing essentially the same information just in a different format here. Again, kind of running out of space here, but with our, what did I say, ogive? I can't keep track of my terms here. This is not an ogive, this is a frequency polygon. So frequency polygon. And we start by graphing a plot for each one, plotting the same information. I have 26 here. I have 14, 2, and 2. And our frequency polygon is going to connect those values and make it a polygon by connecting down to the x-axis on this side and on this side as well. So a frequency polygon, not an ogive. Frequency polygon here. Our last graph then is an ogive. I'm going to have to disappear that information so I can make my graph, so I might have to scroll up and down here a little bit to get those numbers. But with our ogive, we'll mark this big and bad here so that we know for sure what we're doing this time. With our ogive, we go back to using the class boundaries. So I'm going to fill all those class boundaries in here. And that gets my class boundaries. If I scroll back up here, I don't need to scroll back up. You should remember we're going from 0 to 100%. So I'm going to go by tenths, 0.1, 0.2, 0.3, and so on, to get all the way up to 100% or 0.1. Now because it is 0.1 or 100%, you can do what I'm doing and use the decimal values, or if you wanted to go 10%, 20%, and so on, you can put your percentages on it here as well. Not a big deal, reading the same kind of the same thing. Okay. Remembering our ogive will always start at 0 on that first boundary. Now I do need to scroll up a little bit back and forth. So our cumulative frequencies are these numbers right here. So we're graphing 4, 20, and 56 to begin with. So 4%, 20%, and 56%. From there, I think we went up to 82. Yep, 82, 96, 98. So we go 82, 96, 98, and 100. And just like our other graph, that was an ogive, it continues up from left to right. And just a side note, this graph will be used later in Chapter 3 to find percentiles. There's our ogive based on relative frequencies, and that covers our 3 graphs for the day: histogram, frequency, polygon, and ogive. But essentially we had 6 graphs because we had the relative versions of those as well. But that covers those graphs.